Good morning, friends. Welcome all of you to my channel on ST1. So far, we discussed about different type of beams, design of singly reinforced beams, doubly reinforced beams, and T-beams. In all these cases, we have mainly focused on design of tension or compression reinforcements, right? Now, today we are going to discuss about the design of shear reinforcement. So you should know first of all what for we design shear reinforcement, or what is the importance of the design of shear reinforcement. We already studied in our theory of structures in a simply supported beam. In a simply supported beam carrying UD loads, the maximum shear force will be at the two supports and 0 at the middle or at the center, right? Here, the maximum shear force at the two supports and it is decreasing and 0 at the middle, right? Similarly, in a cantilever beam also, the shear force is 0 at the free end and maximum at the support, right? So far we designed the beam for the bending stresses only, right? The longitudinal direction, the main reinforcements in the longitudinal direction, either tension steel or compression steel. Now, to take the shear stresses, we have to design the shear reinforcements also. So that is the importance to prevent the diagonal tension and the cracks developed due to the diagonal tension. Usually the diagonal tension will occur at the support or near the support to the top at an angle of 45 degrees, right? So the shear reinforcements to be designed to prevent this diagonal cracks developed due to the shear stresses developed. It's okay. Now, what are the different type of shear reinforcements? Usually, shear reinforcements are provided as vertical stirrups. You might have seen in beams vertical stirrups covering the top and bottom longitudinal reinforcements. It may be a two-legged stirrup or four-legged stirrups. You might have seen this, right? When we cast beams, rings are formed, stirrups are formed. These two vertical legs, here four vertical legs. So that is known as four-legged stirrups. So that according to the design of shear, will either provide two-legged or four-legged stirrups. That we'll explain when we will solve the problems on the design of shear reinforcements. Now see here, the longitudinal section of the beam is the longitudinal section of the beam, the tension reinforcement at the bottom, the compression reinforcement or the hanger bars at the top, and covering these, the vertical stirrups are provided. Now from the figure it's very clear that the spacing of reinforcements, the vertical reinforcements, shear reinforcements, this is very less near the supports, whereas the spacing is more towards the middle of the beam. Why it is so? Because to the same reason. The shear is maximum at the support and 0 at the middle. It's decreasing to the middle. Therefore, we can increase the spacing. We can reduce the number of bars. We can reduce the number of shear bars or stirrups near the middle. See here, the spacing is increased. And here the spacing is very less. SP is the notation for the spacing of shear reinforcement. So that is the importance of shear reinforcement and why it is provided in the beams in addition to the tension or compression reinforcements. Okay. Now, for the design of these shear reinforcements, you have to refer IS 456 and also SP16. In IS 456 in page 72 and 73. You can refer page 72 and 73 to get the design data, the requirements, how to find out the spacing of shear reinforcements, about the shear strength, what about the nominal shear stress and design shear stress. See, nominal shear stress is denoted by tau V and design shear stress by tau C. So when the shear is very minimum, we can provide the minimum shear reinforcement or nominal shear reinforcement, right? If tau V is less than tau C. If the nominal shear stress is less than the design shear stress, we can provide the minimum shear reinforcement as per the clause given in the code, say 25.516. In clause 25.516, the minimum shear reinforcements to be provided, the relation is given, right? And if tau V is greater than tau C, in that case we have to design the shear reinforcement, vertical or inclined or both, right? For that you can refer IS 456 and also SP16. Also you can refer page 175. The same data are given in page 175 for the design of shear reinforcements. So all that design particulars will consider while we'll solving problems on this design of shear reinforcement. So today we have discussed about the importance or the purpose of providing shear reinforcement in beams and what are the design criteria of a shear reinforcement. So that is, when we consider a beam, the design of any beam, whether it is singly reinforced, doubly reinforced or T-beams, in that case the shear reinforcements are necessary to take the shear stresses to avoid or to prevent the diagonal cracks at an angle of 45 degrees. So that shear reinforcements will be provided from the supports to the middle with the less spacing at the supports and more spacing near the middle of the beam. Okay, now there are two types of stirrups, 2-legged and 4-legged stirrups according to the design value of the shear stress. Okay, I think it is clear to you. So in the next class we will solve problems on this, the design of shear reinforcements. So today we wind up the class now. Okay, thank you one and all.